Hey everybody, so this video is to talk about variations, of which there are four kinds: direct, inverse, joint, and combined. Um, so this is all going to be one video because these notes are going to be fairly short. So let's focus on the first problem that we have here. If y varies inversely with x and y is 18 when x is 28, find x when y is 30. So you should have read in the notes earlier that a problem will always tell you what kind of variation it is. And this one's telling us right here that it's inverse. So if we look back at the chart that we had, you can see that the inverse variation relationship is y equals k over x. So we're going to write y equals k over x. That's the relationship we're going to use. And then they tell us a known set of information that y is 18 when x is 28. So we're going to plug those numbers in for x and y to calculate the constant of variation, which if I multiply both sides by 28, that would tell me that that constant of variation is 504. So really in this problem, the relationship between x and y is 504 over x is what y equals. So now we want to find x when y is 30. So we take that 30, we plug it in for the y. Draw a little arrow there. And we're going to solve this thing for x, which we would do by multiplying both sides by x and then dividing by 30. And that comes out as 16.8. So these variation problems are pretty much all the same. You read the problem and get the type of variation. You get the formula for that type of variation. You use a known set of information in the problem to find the constant of variation, and then you answer the problem. So, pause the video, work the problem below. This is a direct variation. So we use the formula for direct variation. We find our complete set of information and use it to find k. Use that to write the equation for the problem, and then answer the question. And that's my answer. Now, sometimes the relationship can involve something more than just the variables themselves. So let's look at an example of that. If y varies jointly with b and the square of q, w is 12 when b is 8 and q is 3, find q when w is 10 and b is 5. So the joint variation equation is normally y equals k times variable, but this says here that it varies, w varies jointly, so it's going to be k times something, with b and the square of q. So it doesn't really make a difference in the actual relation, in the actual setup of the equation. It's just what you put in there as one of the variables is not just the variable itself. And then we're going to follow the exact same process. Get a known set of information and use it to find k. 12 over 72, by the way, is 1/6. That's the relationship in this problem. And then we're going to use that to find q when w is 10 and b is 5. So let's see, that's 5/6 here, so I divide both sides by 5/6. That's like multiplying by 6/5, which I believe is going to give me 12. So q would be the square root of 12. Technically plus or minus the square root of 12, since I didn't say it had to be a positive number. And we would get a decimal for that. All right, so problem below, do it. It's an inverse variation, and it involves the square root of v. Find the known set of information, plug it in, solve for k, write the equation. I'm going to leave this as a root so I don't have to round, and then solve the problem. All right, last problem. Essentially, combined variations are exactly what they sound like, a combination of inverse and direct variation. So I've got a problem here that involves the ideal gas law, which you should have talked about in chemistry. Volume of a gas varies directly with its temperature and inversely with its pressure. So what I'm going to do is write this relationship out and then go to quick workout mode. So the volume of a gas, the way this works, it varies directly with its temperature. So normally you would write KT, right? And inversely with its pressure. So normally you would write K over P. But since we want to have one combined variation here, we're going to put this all into one problem, where the T is indirect variation, as you can see. But if I put the P underneath the K, then it's inversely operating with the volume, and it involves both the direct and the inverse at the same time. So then the rest of this just goes as normal. There's the known information. I solved for k by multiplying by 75 and divided by 30. So now my relationship is this. And now I'm going to answer the question. And notice because this is a word problem, I went ahead and put units on my answer as well.